with Dr. Dezhaou Liu. Dr. Dezhaou Liu is a CJU 100 professor, thank you, at College of Biosystem Engineering and Food Science, Zhejiang University in China. He was chairperson of the 8th IWA Odour conference in 2019 in Hangzhou in China. The title of his speech is Influence of Organic Odorant in EO Production During Ammonia Abatement in Biofilm Technologies. I think it's a video and we start?
Yeah, it's a video.
Yes, thank you.
Good morning, everyone. This is Dezhaou Liu from Zhejiang University, China. First of all, I apologize that I could not be attending the conference on site due to the isolation regulations in China and the fact that I have a lot of teaching for the period. Secondly, I'd like to thank you for all of you who have attended the last conference in Hangzhou 2 years ago. And here, I'd like to share some of our recent results from the last conference. And today, my speech is about influence of organic odorants on nitrous oxide production during ammonia abatement by biofilm technologies. This is the outline of my speech today. As we all know that the livestock production in China has been increasing for the last years, and it's actually also influenced a lot of environmental problems. For example, the intensive production is significantly increasing in China, and odor nuisance is often cause complaints, especially for the neighborhood where in the east south of China. And these odorants, they are typically within low concentrations, and measurements are different and also reduction. And sometimes we have large or very large ventilation rates. So for this case, for the low concentration and also high ventilation rate, usually we are considering to use some biofiltration technologies in order to remove the odorants, because biofiltration is considered as safe and low operation cost, and also can remove, for example, ammonia and plus the different odorants at the same time. Also, from the engineering point of view, we have generally a basic setup for the biofiltration process, but in theory we have a rather complex process because it can be influenced by the kinetics, the mass transfer, the residence time, the nutrients, temperature, the loading, and inhibition. From my point of view, the bioavailability is very important for this process. And from the livestock odor, we have actually usually it's very low concentrations to be measured. For example, only ammonia is a bit high concentration from 2 to 50 ppm, but other odorants like the sulfur odorants, the acids, the phenols, they are all very low concentrations. And because of the operation cost consideration, usually we have very low residence time or empty bed residence time for the biofiltration process. And because of this low residence time, and sometimes we are facing a problem with the low removal efficiency. For example, for the sulfur compounds, including the dimethyl sulfide, hydrogen sulfide, and methane sulfide, for example. At the meantime, the ammonia removal is not as high as hoped. Another question is that the nitrous oxide production is also a problem because this is a greenhouse gas. And this process can be influenced by nitrification, also the denitrification, and also maybe because of the oxygen distribution in the biofilm in this biofiltration process. Therefore, the objectives of this study is that we like to look into the reduction of mixed odorants by biofilm technologies, including biofilm, the biofilters, and the biotrickling filters, and also the production of nitrous oxide while treating mixed odorants, including ammonia, and the nitrous oxide production route and mechanisms. While we are going to evaluate the organic odorants and the carbon source influencing on the nitrous oxide production, and organic sulfur odorants removal if we can actually optimize organic sulfur odorants removal when we have a low residence time. And we typically use some lab scale the biofiltration biofilters, biotrickling filters. Plus, we have also some trials on the field scale. And here are some instruments we used for the measurements. Typically, we use the GC mass for the VOCs and some other instruments for the ammonia and hydrogen sulfide, for example, and nitrous oxide we also DC, for example. And previously we tried with the biotrickling filters and for the nitrous oxide production, and we saw that actually the nitrous oxide could be controlled under 3%, but we actually have to have a good control for the biofilm, and also we did not do that for the longer period. We have to do something for the controlling process. And for the biofilm, for the biofilters, we can see that the nitrous oxide is actually largely produced, especially for the later process, depending on the humidity level. And the results from the side preference from the nitrogen isotope analysis suggested that the nitrous oxide production is actually mainly from the nitrification plus the denitrification. And the possible reason it might be because the bacterial nitrification plus the fungi denitrification. And also we look into the organic odorants to see the influence of the organic odorants on the nitrous oxide production on this process. And we use 4-methyl-phenol or p-cresol as a typical odorant to see if there's an influence. And for the p-cresol, we can see from the biotrickling filter, the removal efficiency is very high. And we change the different loading of the ammonia and the hydrogen sulfide at the meanwhile to see the influence on this odorants removal. And we observed that ammonia removal is actually very, very good, but the hydrogen sulfide is influenced by the p-cresol load. Basically means that when we have the p-cresol, the hydrogen sulfide removal is a little bit high. And when we looked into the water concentration for the nitrogen, we can see that nitrite accumulation in the water phase when the p-cresol was absent, was not present, and mainly suggested different microbial activities from when we have p-cresol or not having p-cresol there. And when we have the nitrous oxide production, it seems that we have actually a higher nitrous oxide production when we have the p-cresol presented, suggesting that the enhanced denitrification when we have the p-cresol presented in the biotrickling filter. And when we look into the microbiodiversity, it seems that with the P. presented, and we have actually a much richer microbiodiversity, and also in the meantime, as we said, it's actually helped to remove the hydrogen sulfide. And we also tried to look into the removal of ammonia, and also in the meantime the hydrogen sulfide and dimethyl sulfide, in order to see if we can actually improve the removal of dimethyl sulfide. And from this figure that we can see the removal with the low residence time, we lower around 3 seconds of residence time, we can see that we have a good removal of ammonia. And for the hydrogen sulfide with the 3 seconds, we can also observe a good performance of 90% of removal of hydrogen sulfide. And while for the dimethyl sulfide, we have a bit lower, and we are thinking about how to actually to improve the performance. Although we have already around 80% of removal, this is actually a better performance than a lot of cases, but we need further improve in the future. So to summarize, we actually try to control the nitrous oxide production to 1 to 3% for the BTF, treating ammonia and hydrogen sulfide, but the biofilters we have a bit more difficulty because the oxygen distribution is actually basically a challenge. And the P. could be organic odorants at the carbon source to enhance the nitrification, where we actually have a higher production of nitrous oxide. And we have a potential to optimize the organic sulfur removal, but we need further improvement. And I'd like to thank you all for your attention, and thanks to my funding sources. And if you have any question, please contact me. And I wish you to enjoy the rest of the conference. Thank you very much. Hope to see you 2 years later. Thank you. Goodbye.